Okay, the first lesson is on squares and square roots, and you can use a calculator for this. Yay! So squaring a number is raising that number to a power of 2. For example, 4 squared equals 16, because 4 times 4 is 16. So that should be a little bit of a review. So this is the new part, and we kind of talked about this in our bell ringer. So when a negative value is squared, you have to be careful to note whether or not the sign is inside the parentheses. So if you observe the difference below, this one is negative 2 squared. So that would be negative 2 times negative 2, which is a 4. But on this one, and you might want to write it down, this squared is 2, and then it's the opposite of. So like I like to write that down here. The opposite of 2 squared. So 2 squared is 4, and then you pull that negative over. So this one would be negative 3 squared, which is 9. This is 3 squared, 9, and then pull the negative in. So this one is negative 4 times negative 4, which is a positive 16. And this is 4 squared, and bring the negative in. And it's just something you really have to think about and take your time on. So then the opposite of squaring a number is when you take the square root, it's the inverse, or you could say opposite, but inverse is a fancy word you should probably know. It means opposite. So the square root of 16 is 4, but it could also be negative 4, because 4 squared is 16, and if you have negative 4 inside those parentheses and you square it, that's also 16. The positive square root, I'm just going to put a positive sign there. The positive square root is known as the principal square root. And when using the square root sign, the solution is the positive square root. So additionally, it says 16 is called a perfect square, and I'm just going to put a square, because its square root is a whole number. So when you take the square root of something, if it's a perfect whole number, then it's a perfect square. So for example, like the square root of 17 is not a perfect square, because nothing times itself is 17. So on my chart in that corner, you'll see that line drawn through the corner. And these are good ones to have memorized. So you can use your calculator right now if you need to. But let's try to do it on your own. So these are the perfect squares. So 1 squared is 1 times 1, which is obviously 1. 2 squared is 4. 3 times 3 is 9. 4 times 4. 5 times 5. 6 times 6. And if you want to pause the video and do it yourself and then look to see what I have written, because that's what I'm going to do right now, is pause it, and then I'm going to write those in, and then you can look back at them again. Okay, so hopefully if you did it right, you got these, if you used your calculator. And these are ones, like I said, you should just kind of try to memorize. Okay, and then for the square roots, to get the answer of 1, that would be the square root of 1, because 1 times 1 is 1. Okay, to get the answer of 2, you would take the square root of 4, because 2 times 2 is 4. Get the square root of 9. Okay, and so if you look, it's going to be all these numbers that are up here. So I'm not going to take the time to write all those in, but if you want to pause your video and write those in, you may, or you should. Okay, so evaluating just basically means to like solve or simplify. So some of these should be easier than others. So this one is that negative 7 squared. So -7 times -7 is 49. Okay. This is 2/3 squared. So you don't freak out. You just do 2/3 times 2/3. And when you do that, you do top times top and bottom times bottom. Okay, the next one is 9 squared, which is 81, and then you pull that negative over. Okay, this one, you just do the square root, so that is going to be 14, and then you pull the negative in. So it's like the opposite of the square root of 196. Okay, this one you don't need to freak out. What times itself equals 0.81? That would be 0.9. This one, since they're two perfect squares, you take the square root on the top and the square root on the bottom, and you're done. Okay, I'm going to have you try some of these. What does it mean when they're right by each other? Should be to multiply. So you take the square root first, and then you multiply. Take the square root, and then add. Take the square root, and then order of operations, you multiply, and then add. This one you should be able to do. This one's multiplying right next to it. And then this one, be careful with the signs because this is the opposite of the square root. And then you have that. So I'm going to go ahead and pause the video and have you write your answers in. Okay, so hopefully you got what I did. If you didn't get these, pause the video again, try to figure it out, ask someone or ask me. And then we have a couple story problems. So it says, a group of 225 students needs to be arranged in a square formation for a halftime performance show. So I'm just going to kind of draw that knowing, well, that's a rectangle, but anyway, we have 225 students here. How many students should be lined up in each row? So basically, if it's a square, both sides are going to be the same, even though my drawing doesn't look like it. And so each row would mean like how many are going to be along here, and then each row. So basically, how long is this side? Well, if it's a square, this side's going to be the same as that side. And so for area, this times this equals that. So what times itself equals 225? Well, you take the square root and you get 15. Ivan's room is a square. It's a better square with an area of 144. What is the perimeter? Ooh, this is a tricky one. So it's kind of a two-stepper. So first of all, if the area is 144, we know that 12 times 12 is 144, or we take the square root of 144. And then since we know that each side is 12, the perimeter is going to be 12 times 4. But we had to find that 12 first.